for part C, f of p equals 3p squared minus 2. Uh-oh, I changed the input. What's the input here? It's p. Is that a big deal that I changed it? No, just remember the input now is p is taking the place of x, right? So what's step one? What do you do? Right, so we need to plot some points. What is this thing going to graph to be? 3p squared minus 2? Think of it as 3x squared minus 2 if it helps. What's the exponent? 2. It's a degree 2 polynomial. What does that graph to be? A parabola. Is it going to pass the horizontal line test? No. So just for good measure, though, let's say p and then y equals f of p. So on your graph over here, this is the p-axis. This is the f of p-axis. We don't need to graph too many points. In fact, if you just identify the vertex, you can figure out what the graph of this thing looks like. This is in that special standard form. It's not that easy to recognize, but let me remind you. F of x equals a times x minus h squared plus k would be that standard form for recognizing the vertex hk. Now, in this example, p is taking over the role of x. Are we subtracting anything from x inside the squaring function? No. So what's h? 0. The first coordinate of the vertex is 0. What's k, by the way? The minus 2. So that's the vertex. So the vertex is at 0, negative 2. All right, so what would be a good point to plug in then for p, for your input? Well, you plug in 0, you get negative 2. We already know that. So how about just 1? So 3 times 1 squared minus 2, what's that going to be? So that's just 3 times 1, which is 3 minus 2, which is 1. You get 1, 1 on the graph. Everybody buy that? What's the symmetric point to that? Just hop over the y-axis, which is acting like the axis of symmetry, and you get to negative 1, 1. That's by symmetry. Okay, is it 1 to 1? Just draw a horizontal line. Not 1 to 1 by HLT. Okay, stop there. It's not going to have an inverse function as is, so we stop there. Now, I will say this. In your next class, you're going to investigate that if you just put in this restriction that p is greater than or equal to 0, then it is 1 to 1, isn't it? Because what that would mean is you erase this whole left part of the graph because p is not allowed to be negative, and then it is 1 to 1, isn't it? And then you could go about replacing f of p with y or whatever the output variable is. Switch p in the output variable, solve for the new output variable, and then you've got your inverse function. But we're not going to worry about that right now.